company. And yeah, as Bill mentioned, I used to be leading machine learning infrastructure team at Netflix, and there we developed this open source framework called Metaflow. In this presentation, I will be sharing experiences that don't only apply to Metaflow. So even if you don't happen to be interested in using this particular framework, I hope that this presentation will be useful for and applicable to other organizations and other frameworks as well. These days, like I'm with the new startup, we co-founded a startup to actually help other companies to adopt Metaflow as well. After it became quite successful inside Netflix, we started having a lot of adoption like across different industries, and we are now doing it full time. So I can actually or maybe Sabine, I don't know if you can hear, maybe you can post a link to our Slack. So in case people want to come and join and chat about Metaflow after this presentation, we have an open Slack where we can do that. But actually, anyway, I wanted to kind of start by telling you a story about what used to be the situation at Netflix. So I joined Netflix in 2017. And at the time, and as many of you know, Netflix has been building recommendation systems for a long time. So when you log into netflix.com, you see all those TV shows and movies recommended to you. And of course, I'm sure that everybody in this audience knows that that's a machine learning system that produces those recommendations. And Netflix has been really focusing on that for many, many years, I believe, over 10 years now. And the interesting challenge and the interesting question that popped up now, I think it's already over 4 years ago, was that there started to be more and more different kinds of use cases besides recommendations. And one reason for this is that, as you probably also know, Netflix is now one of the biggest movie and TV studios in the world, producing a lot of its own content. And producing TV shows and movies is actually quite a complex endeavor overall, and they have many different problems, and just kind of it takes hundreds of people to produce a movie and so forth. And now you can imagine that there are lots of opportunities for different machine learning and data science techniques in the process, in the course of producing, let's say, the content. And of course, Netflix is a global business, so in optimizing the business overall. So what started happening is that we started hearing about use cases like somebody wanted to use natural language processing to maybe analyze different textual content that Netflix has. And in other cases, maybe somebody on the more a business side of the house just wanted to predict churn, meaning that how long people keep subscribing to Netflix, and what kind of things keep people using Netflix, and what drive them away. And that's of course something that we could do with the predictive model. And in some other cases, this is one of the more really interesting use cases that when you are shooting a movie, there are many different people who are involved, and different actors and whatnot, and they have to be at a certain location at a certain time, and there are many different locations, and now it's just optimizing their schedules, just optimizing the calendar so that the right people are at the right spot at the right time. It's actually an interestingly complex optimization problem, and you can apply different optimization techniques from operations research like mixed integer programming and so forth to optimize those production schedules. So pretty fascinating stuff. Then lastly, as you can imagine, of course, Netflix happens to have a lot of video content. So there are tons of opportunities for applying computer vision to do all kinds of things, and understand what's going on in the content, and maybe speed up certain things during the production process. And overall, the theme is not that the AI would be producing the content necessarily, but I mean more so that we can just make people working on these things more productive and more effective, and overall make their work more pleasant. But now, as many of you who are ML practitioners know, these use cases here, if you think about NLP, if you think about computer vision, predictive models, maybe even something like mixed integer programming, they have very different techniques, and you probably want to use many different kinds of frameworks. Also, the data sizes are quite different. The nature of data is quite different, and also the kind of the life cycle of these projects is at very different phases, in a sense that in some cases we had a very good idea. Let's say, maybe for predicting churn is a well-known business problem that we will be able to do it well. In other cases, let's say in computer vision, it's purely experimental and we have no idea if that's even going to work. So then different projects had different needs. Different projects were at different points in their journey towards something that's really production ready. So the interesting question became, for my team, the machine learning infrastructure team, that what is really common about all these projects? And like, is there some kind of an ML platform that like we could provide to help all these different use cases? And now, of course, like many such platforms exist. And like, of course, if you, let's say, focus on deep learning, like let's say with TensorFlow, you can use something like DFX, and that really helps in that domain. And similarly, like maybe with NLP, you can use Spacey, I mean, like for certain problems. But I mean, of course, then like when you switch to another domain, like let's say churn prediction, it's yet another use case. So the interesting challenge here is really that like, is there something that's common? Is there something that is really something that like we could provide as a unified horizontal platform for all of these use cases? And now when we started thinking about it, like from the bottom up, well, I mean, one thing that's kind of really obviously clear is that like all these projects need data. The data types may be different. Some projects need tables, other projects need like just unstructured text. In other cases, maybe you need some kind of a metrics, and like, of course, computer vision is images and video, but at least you have data, and like oftentimes you may have like some pretty large amounts of data as well. Of course, the volumes like vary hugely. So the computer vision might be dealing with petabytes of data, and some like a metrics-based predictions might be demanding and complex, but I mean, might have only like, let's say 1 gigabyte of data. So they're like at least like a 3 orders of magnitude difference in the order in the volume of data as well. Interesting challenge infrastructure. So what else? What else is common? So if you think about it, so here's data, like these different use cases, different algorithms. What else is common? Well, I mean, it's easy to see that like one thing that's common is that like all of these guys need to perform some kind of a compute. They need to process some data. They need to run some compute intensive algorithms. And in our case, Netflix has been using AWS for a long time. These days, it's rather non-controversial to say that, well, I mean, being able to run this compute in a scalable manner in the cloud is very useful. So the idea was that, okay, so can we make it easy to run these compute intensive algorithms in the cloud easily? It's a very basic need. Now, when you think about projects like this, when you think about an end-to-end project, let's say for computer vision or like NLP or even churn prediction, well, I mean, one thing is that you build the model and you run the training algorithm. But as you know, that's not all. There's also maybe some data pre-processing you have to do, and like maybe after building the model, maybe you build like a whole suite of models, and then you choose the best performing one. So it's like more like AutoML style, or maybe you want to do hyperparameter search. But long story short, it's not only a single compute step that you want to be performing, but rather it's really a graph of different steps. It's kind of a workflow, however you want to call it. So the idea is that, like, let's say for churn prediction, it might be that you have first data processing and data pre-processing, and then you train a model, and then maybe you publish the results. And for something like computer vision, it can be a really complex thing, like where you have to do like all kinds of like a computer vision specific pre-processing maybe, and then you maybe build like different kinds of models. Maybe you shard the data somehow. Maybe you build a different model for every title, every movie, and so forth. And the same thing. So like for these other use cases as well. The point being that there isn't a single universal workflow that would work for all these different projects. So every project has their own specific needs. But again, the idea that you can express these projects as some kind of a directed acyclic graph or as a workflow, I mean, that seems to be quite universal. So again, I mean, something that like we could provide as a common service. Now, another like really interesting thing, if you think about like, especially like doing projects like this in a larger company, well, what tends to happen is that, well, I mean, maybe there's a single data scientist starting the project, but over time, it might be that it's not only a single person working on these things, but it's actually a team. It's a team of data scientists. And now, I mean, maybe they're like working on a workflow, but I mean, it might be so that maybe they have like one workflow, and then a colleague builds another kind of workflow, makes tiny adjustments. And like maybe they like want to test one version, and then like they want to like test another version on the side. So what becomes really important that like you're able to version these things, you're able to kind of really stay quite organized when it comes to this like a day-to-day work, like and collaboration between different data scientists. So if you only like, I mean, this is like if you have done any software engineering in the past, I mean, this is the reason like why software teams use systems like Git for version control, that it would be absolutely impossible to develop like any non-trivial piece of software, like without making commits and like without having a repository and like without being able to keep track of all the changes that have gone into these systems. And interestingly enough, like when it comes to machine learning and data science, this is still a bit up in the air, that like what's the best way to handle this versioning and experiment tracking and so forth. So of course you can use Git to version your data science code and machine learning code, no problem with that. But then, like, you don't only want to version the code itself, you also maybe want to version the models. You want to understand that, like, well, I mean, this is the model produced with this data set, and like your colleague produces another model, so you want to version the models as well. And whether you want to version the models using Git, I mean, that starts getting a bit hairier. And it goes even beyond that. I mean, maybe you want to version the data as well. Maybe you want to understand how the model was produced. And like there you want to have like the data included in the kind of a snapshot as well. And now again, I mean, there are many projects in this space, like when it comes to experiment tracking, like a data version control, like model repositories and so forth. But I mean, again, I mean, this is still like quite a nascent field, and like especially back in 2017, I mean, it was even more so. Well, now if you take even a step further, like one thing that's really obvious is that, of course, like even a company like Netflix at some point realized that it's pointless to implement these really like the machine learning algorithms and the kind of the implementations of these methods like from scratch. Actually, like Netflix used to do it like a long time ago, but like these days, projects like TensorFlow or scikit-learn or stats models or PyTorch, they're actually like so well optimized and like so polished, and like so much like work has gone into them that it totally makes sense to, of course, like leverage these open source frameworks whenever possible. But also it poses an interesting problem that, well, I mean, first, at least at Netflix, different projects were able to choose the frameworks they use. So it wasn't so that everybody was forced to use scikit-learn or everybody was forced to use TensorFlow, but it was so that, of course, like a different use cases require different problems and different packages. So for instance, for text, you might use something like Allen NLP or Spacy. For images, maybe you want to use PyTorch, like for something like churn prediction. I mean, like there are like really nice implementations in scikit-learn and so forth. So forcing everybody to use a single framework doesn't seem like a good idea. So letting people use different frameworks seems something that we should be able to support. Now, another interesting challenge is that all these frameworks, as you very well know, I mean, are also like a fast moving entities of their own. So there are new versions of TensorFlow, there are new versions of scikit-learn and so forth. And now imagine like having a production workflow like this, and suddenly TensorFlow changes. Well, I mean, it can cause like very like adverse impact on the production workflow. So somehow like you need to be also disciplined with these upstream libraries that you are using. And it's one thing that you can run import TensorFlow in a notebook. It's another thing that like you can use, let's say, TensorFlow or scikit-learn in a reliable manner in your like a production workflow. So then now, I mean, like just by going through this, like a simple thought exercise that, okay, we need data, we need compute, we need workflows, we need versioning, like maybe with that, like we need some kind of a dependency management. You're starting to see that there's actually a bunch of things that data scientists need to care about. And like, hence, like we like kind of ask ourselves this question that like, would it be possible to kind of at least address these basic questions in some kind of a unified framework? Because of course you can solve each one of these problems like a case by case basis, and like let's say you could use just like Kubernetes for the compute, and you can use Airflow for the workflows, and like you can use DVC for the versioning, and you can use CometML for experiment tracking, and you can use Docker like for dependency management. But now you kind of have another problem that you have introduced a whole another level of complexity for data scientists. And we felt that, well, those are the questions that they shouldn't be needing to think about like every time again and again. And like maybe we need a single framework that can help with them, help with those questions like in a very coherent manner. And that was really the motivation, like for us to start building Metaflow, like already back in 2017. And now it's open source at metaflow.org, and you can go and take a look. But I mean, the basic philosophy is that exactly like what I mentioned about like starting with this like very basic concerns, like can we help people with data? Can we help people with compute? Can we help people execute workflows in a reliable manner, both locally during prototyping as well as during production? And then like when you have larger teams that like work on these things together, like can you make it easy for them to collaborate? And then like at the higher levels, I mean, we have questions that, okay, how do you architect more complex applications? So in some cases at Netflix, there are like these ensembles of models that have even hundreds of different models. And by the way, if you're interested in this, like more architectural questions, I encourage you to join Will High's talk. Is it next week here at the AI Camp? So I'm sure that he will dig deeper into that question. Then there are questions about the model operations, like here, I mean, like questions like just monitoring the models and like making sure that like kind of the results stay valid and so forth. And then at the top of the stack, like we have, of course, this like really the bread and butter of data science and machine learning, that, okay, how do you do feature engineering? How do you do model development? But I mean, the way how we think about it is that when it comes to this lower level concerns like data compute, workflows, versioning, at least in our experience at Netflix, these were the things that like the data scientists kind of didn't care so much about, in a sense that everybody just assumes that you should be able to get the data. Everybody assumes you should be able to run compute at any scale. The workflow should just run. It would be nice if you don't even have to think about versioning. It just magically works. But I mean, then like at the higher layers, then people, of course, and like our domain experts and data scientists, they are like really kind of, this is what they do for a living, and this is what the company is paying them to do, that they really understand model development. They even like understand the data in their domain really deeply. So it totally makes sense that like the infrastructure is kind of less opinionated at the top of the stack, but then conversely, like more opinionated at the bottom of the stack. And that seems to be a kind of a good division of work, like between these two different like roles at the company. So let's say my team was a machine learning infrastructure team. So we were really kind of starting from the bottom up, like helping people with these very foundational questions about infrastructure. And then the data scientists working on all these different problems, they could choose the models what they want. They could like understand, like spend time understanding the data in their domain. We were not too opinionated about it. And then, of course, like even like we asked them to operate these models in production. And this is actually something very important from Netflix, that that Netflix overall like trusts very much like every employee to be able to own their like area of expertise. And we didn't have the kind of the, let's say, the old school model, like where you had a one person like kind of building the model or doing the research, another ML engineer like then implementing that in another language, and then like maybe some application engineers then operating it in production. But in most cases, in most applications, it was the one and single person who were asked to kind of both the kind of the architect the whole thing, like understand the data, build the models, and then also operate these models in production. Now, as we will like talk soon, like the production, it can mean like very many different things. But the idea was that that's of course a kind of a big ask, and that's where also we felt that the infrastructure can really help. So now I actually like want to go a bit deeper, like on that like question that, well, I mean, what does Metaflow actually do? And I thought that like a good way of kind of really introducing the concepts is to think about a project life cycle. So now pick any of these projects, what I mentioned, like NLP or computer vision or like a churn prediction, like what have you. And like I'm sure that like many of these things apply to your own projects as well. And this is the kind of the basic idea how oftentimes you hear people talk about these things, that like, well, I mean, like data scientist, machine learning engineer starts prototyping something on their laptop. And then like eventually the idea is somehow that this thing, whatever they have built on their laptop, like goes to production. And the production is that like a big scary thing that like somehow, especially like what we kind of, when people say production, it's kind of funny that like there are many different connotations what production means, but there are like a few things that are universally true. I mean, one thing is that, well, I mean, it needs to be highly available in the sense that it shouldn't crash, at least it shouldn't crash too often. I mean, that's usually a requirement. Another important requirement is that it kind of more or less like it should run automatically. So if a human being needs to press a button, like every time to let's say train a model or something, and then it kind of feels that maybe it's not quite production ready, especially if it runs on your laptop. So that's like another big one. And also like there's the assumption that like it needs to scale to whatever like a scale your problem might require. But I mean, other than that, it's a bit hazy that like what is exactly meant by production. So when you hear like a companies and like presentation talk about ML ops and like kind of going from prototype to production, it's kind of oftentimes like left a bit in the air that like what exactly is meant by production. And like when we started thinking about this thing, like we took this approach that instead of like having a very like a binary division between prototype and production, like we saw it more as a spectrum, that there's a journey, it's a path like from prototyping to production. And it's not like not like a black and white thing that like you have a prototype and then like it moves to production. And of course, in the older days, maybe it was so that like the prototype meant a Python code in a Jupyter notebook, and production meant that you implement something in Scala or Java and it runs in some like a fancy microservice platform. But I think that like what's really important, and this is really important for productivity of data scientists, is that it's actually a continuum, it's a spectrum, and like there isn't like any kind of a hard gaps in this line. So I want to kind of walk you through the kind of the path that like we had at Netflix, which like turned out to work pretty well, and like I hope that could work for you as well. And like I'll again, I mean, I'll use Metaflow as an example, like kind of how we implemented this, but I mean, of course, these concepts are quite universal. So I'm sure that like if you use other frameworks like Qflow, or like if you use MLflow or some combination of these different tools, I mean, you can see the kind of the similarities in the ideas. And the first one, like I want to talk about, is that like here I kind of drew laptop. So, and then there's the kind of the idea that, well, I mean, maybe you kind of hack stuff on your laptop. That's what like many people do these days. But one thing that like we found like tremendously useful is actually this idea of having a cloud-based workstation. Like it's a very like a no-brainer idea. Then now instead of developing your like models or like just like doing the actual like day-to-day work on your laptop, well, I mean, like what if we can provision you a kind of a workstation in the cloud? So basically an EC2 instance, if you're more technically minded, maybe running some Docker container. That is the way how it's set up at Netflix. So there's a UI like where anybody can go and like press the button and it provisions you basically a Docker container in the cloud on an instance of your choosing. And the benefit of that is that if you look at this picture here, is that, well, I mean, the production environment is anyway in the cloud. I mean, I hope and I presume that like nobody like runs production on their laptop. So most likely it is some kind of a Linux server in the cloud. What's the production environment? And now if you do development on your laptop, there's actually like quite a big gap between the production environment and your laptop. I mean, one of the biggest gaps is actually like the operating system. So maybe many of you use OS X, like Apple machines, or like even Windows, and like, but on the other hand, like most servers these days, they run Linux. So it's already like a very, very different system. And like, while in many cases with many frameworks, like if you use Python, kind of it shouldn't make a huge difference. But I mean, especially like with some like more computationally intensive things, like maybe you need to kind of have really low level libraries correct and so forth, it can actually make a difference. So like, let's say that like you are able to kind of provision the cloud workstation. So then you are like much closer to production environment already. And now on this cloud workstation, like you can run notebooks, you can run your like IDE. So let's say if you use something like Visual Studio Code, you can use this workstation as a kind of a remote backend for Visual Studio Code. So you can still, of course, do all the code editing on your local machine, but like the actual like execution happens there in the cloud. And like, yeah, I mean, for the terminal access, you can use the workstation. And now, like, what's really important that then like all the questions related to the accessing other cloud services, let's say Amazon S3 and so forth, it becomes much easier because it's kind of within the same security setup as everything else in the cloud. So when it comes to data governance and security, the idea that people are not downloading stuff on their laptop is really quite useful. And now the kind of two important like kind of human workflows that we like really wanted to optimize for is one, like you can see this like small ellipse here, like which is that like, well, there's the data scientist like hacking stuff on their cloud workstation, like doing development locally. This is kind of the prototyping cycle. I mean, you hack some code, you run it locally, you test like if it works, and actually like making that like prototyping cycle really efficient is very, very important, because like that's where you spend like most of your time. But then also there's the bigger cycle, and there's the question that how do you interact with the production environment? And that seems to that should be like pretty smooth as well. So it shouldn't be a huge leap to go from the cloud workstation to some kind of a production system. And again, I mean, that's where kind of the workstation is kind of like helpful in like bridging that gap. But I mean, these are the kind of the two big cycles that like we were thinking about. So I mean, of course, I mean, this is like a very, very basic thing. So, but I mean, it's kind of I'm still like kind of surprised like how few companies have like properly invested in like making this easy enough. Then the kind of the next thing that I definitely want to address is this question of notebooks. I'm sure that like many of you are quite familiar with Jupyter notebooks and maybe different kinds of notebooks, and many data scientists really like to use them. And the way how we think about notebooks is that notebooks are really great for exploration. Like when you have a new data set and like you just want to understand what's going on. I mean, definitely like a good tool for that. Also, if you want to maybe like a dabble with some new APIs, maybe build small scale models, like why not? I mean, that's all good and fine. And especially of course for visualizations that like you want to kind of like create some charts and plots. So, I mean, of course, notebooks are like absolutely perfect for that. But also, like as many of you know and like may have experienced by yourself, like it's like quite easy to kind of end up with quite messy notebooks. And like as a software engineering artifact, it's hard to kind of maintain the discipline. I mean, I know that it's of course technically possible, but I mean, it's just hard to maintain the discipline of kind of keeping kind of notebooks quote unquote production ready. So this is to say that like we definitely want to embrace notebooks for like things where they are really good at, but then like try to be realistic like with things like where they don't work so well. I will show some examples like what this means in practice soon. Well, now the question is that if not notebooks, so like what kind of a code are you supposed to write then as a data scientist? Again, I mean, going back to, okay, let's say that this is an NLP project, and like, okay, so you can use space in a notebook, but I mean, like, okay, if we say that notebooks are not somehow appropriate for production, so what do you do then? Well, that's like where this idea of structuring your code as a workflow really comes in. And now, for instance, like in the case of Metaflow, we deliberately like wanted to keep it very approachable in a sense that if you are able to write code in a notebook, you should be able to write code as a Metaflow workflow as well. And here's like a very simple example that you have this DAG of two nodes. You have a start and end. Like all you have to do is just define this class, like it derives from this flow spec interface. And now there's a one-to-one correspondence between these steps that you see here in the graph, and then like these methods that you see in the code. So there's start and end, and the edge between the kind of the nodes is like a self.next. So the start goes to end. So you can see that it kind of this code here one-to-one defines the graph. And now the idea is that like here, like within these functions, you can write any Python code you want. And this is important going back to the diversity of use cases that we had to support, that there are many other frameworks that are much more opinionated, even so that they don't let you write arbitrary Python code. And that's all good and fine if you happen to have a very specific problem domain or like a specific type of models that you need to build. But as soon as you have to support like all these different kinds of things, it would be hard to say that like, well, you have to do things in a certain way. So you can write any idiomatic Python here instead. So now, like the question is that like many of you may look at that code and think that, okay, that's really quite trivial. I mean, nothing too special here. Now, I mean, like you can test it locally, you can run it on your laptop, you can run it on the cloud workstation, and it works. But I mean, it kind of feels that it doesn't do much by itself. Well, I mean, one thing that Metaflow does out of the box is that actually whenever you execute something, it actually keeps track of those executions at the centralized metadata server. And not only it keeps track of the executions, but like especially like when you run things in the cloud, it also snapshots your code. So you don't necessarily like have to kind of make commits to Git every time you run something. And this is something that we felt that, especially like as you are like intensively prototyping something on your local machine. I mean, the idea that you have to make commits every time to Git when you run an experiment. I mean, that's kind of like, I mean, just like additional overhead. So instead, Metaflow can just kind of snapshot that code automatically for you. So we snapshot the code. We also snapshot the internal state of the workflow. So it's actually like quite handy for a number of reasons. One is that now you can use notebooks, like exactly as we discussed, that like use notebooks for the things they are good at, like which is like kind of just looking at the internal state, looking at the models, creating visualizations and so forth. And like it's almost a way of doing experiment tracking. You can kind of even have a custom notebook where you can kind of really visualize exactly the things you are interested in, like when it comes to your project and your model. But then like another really important thing about keeping track of the kind of the state is that like when things fail, like you can always easily go back and like see that like what was the state of the workflow like at the time of failure. And all these things are something that like you kind of get out of the box, like when you use Metaflow and like when you just like structure your code as a workflow. So that's already kind of a step forward, like from just like kind of hacking stuff in a notebook. Well, the next question, now imagine that like you start creating something, you have created this workflow. I mean, yeah, it versions everything, all good and fine. Typically, the next problem that people hit is that they may have started experimenting with the small data set, maybe even like tiny CSV, but then like everything seems to be working with the small file. But I mean, what if you want to kind of test it with the larger scale data, or like maybe your model is more demanding and maybe you need now GPUs, maybe you didn't have GPUs originally, or maybe you need more GPUs. And now a challenge is that there isn't a magical button that like would increase the size of your laptop. And well, there could be technically a magical button that increases the size of your cloud-based workstation. But I mean, it might be inconvenient to kind of keep kind of changing that like workstation all the time. So Metaflow like provides another way, which is that you can just annotate the code. If you know that let's say the start step here has a big pandas data frame and it needs 128 gigabytes of RAM to be able to hold this pandas data frame in memory, you can just say that this function needs really this much memory. And then what happens is that like when you execute this code, now using, in this case, AWS Batch as a backend, it goes to the cloud and it provisions an instance like with this much memory, like for this particular function. And the beauty of that is that that instance is only being used like for the duration of this function. So immediately, like when the function ends, the instance can go away. So you only kind of end up paying like for the kind of the absolute the minimal amount of money, because like nowadays, for instance, AWS prices by second. So, I mean, like if this function executes for like a 45 seconds, I mean, you only pay for 45 seconds of the instance type. So it's actually like a super convenient way. And now maybe it used to be so in the past that your company said that like, no, I mean, we can't have these large instances with this much memory, or like even half a terabyte of memory. But I mean, that is starting to be less and less true because of the dynamics of the cloud. So this really like, it's actually like kind of almost feels like superpower that now. Imagine that like in a notebook, you have this data frame, and like it used to be so that the notebook crashed because like the data frame is just like kind of a little bit too big. Now, instead of changing your code, you can just say that, okay, whatever. I mean, let's just like use a bigger instance and it will work. Now, it's easy to see that this is, of course, like not a silver bullet solution to all scalability problems. Of course, like eventually it's possible to have data sets that don't fit on any kind of like computer, like in the existence in humankind. But the surprising fact is that like surprisingly many problems actually can be handled on a single powerful server. And this is actually especially true for training. And like if you get like one of these beefy boxes with maybe 4 or 8 GPUs, like you can actually train an absolutely massive scale models on such a box. And the same thing goes with the data processing as well. That of course pandas tends to be pretty memory hungry, but still, I mean, you can have a big box with like hundreds of gigabytes of RAM and you can do quite a lot. And the big benefit here is not so much technical, but rather the fact that the user, the data scientist, doesn't have to change anything in the code. So it is actually like really a productivity boosting feature more than anything else. Well, of course, the next question is that like, well, I mean, what if I have a larger scale problem and I just can't handle it on a single machine? Well, I mean, of course, those use cases come up quite often. And in those cases, you can rely on this idea of horizontal scalability, or like the simple idea of using many computers instead of a single one. And Metaflow makes this quite easy, that you just basically define any kind of a Python list and you say that, okay, I mean, here are like 100 things. And you give 100 things like to this, like to the kind of the next function, and then Metaflow will automatically then like launch like 100 instances. You can actually control like how many instances are running in parallel. It could be less than 100. So in which case you kind of do it in batches. But the basic idea is that this way you can like basically just like a farm out the compute to the cloud. And interestingly enough, now, well, I mean, within these individual instances, you can train models, you can do hyperparameter search, you can handle different shards of data. But then at some point, you kind of need to come back and you kind of need to do this like a fanning in. You have to choose like kind of, okay, so what do you do with the results? And interestingly enough, like usually it's like a fanning out, like just like a pushing stuff out. It's almost like the easier part than like deciding like what to do with all the results. It's actually like can be harder because you have to collect all the results and like make sure that the results are all valid and correct. And also this is like, it's pretty easy. You get this list called inputs, and then like the inputs refers to kind of all the results that like were like coming in like from these individual containers. And then you can decide, like a typical case might be that you choose the best performing model out of all the ones that you trained, or maybe if you kind of like a sharded your data and like you handle different shards separately, like you can like produce some aggregates or like what have you. Of course, like many of you may recognize that this is pretty close to kind of like the famous MapReduce paradigm. So these are your mappers, and this is the reduce or like a fork and join. So it's a very common pattern and like works well for many different kinds of use cases. Now, the next thing that we faced when people started running compute at scale is this question that, okay, now I have these 100 containers running in parallel. And if, let's say, I want to access some data from my data warehouse, from my database. Now, imagine like having those 100 containers hitting the database concurrently. Now, like really imagine that they run at the same time. in the cloud really in parallel. So now you have 100 connections going to the database, hitting like trying to execute SQL queries, and like it's quite possible that like you can take the whole database down by having that like a distributed denial of service attack against the database. So it doesn't make your database admins too happy. So we started thinking that, okay, what are some better ways of accessing data? And this is a pattern that like we used quite successfully in many projects. So one thing is that even outside the domain of data science and machine learning, there's of course the whole like a question of data engineering, and like in many companies, data engineers these days use, let's say, Spark, and like many of these ETL pipelines are like expressed as SQL. And you can like now use systems like Spark, or maybe these days Snowflake or Redshift or what have you, to actually like do all the ETL work with SQL and so forth. And the kind of the input of that like could be some kind of a source table that like you can use in different machine learning projects. Now, this is specific to kind of this like relational data. Of course, like the computer vision use cases and stuff are like quite different. But then the idea is that, okay, so how does the data scientist then like access these results? So one pattern that we had, which was really nice, is that like you can even like then define a piece of SQL that maybe you want a subset of data in the source table, maybe you don't want all of it. So you can like execute this create table as select query, like with, let's say, Spark. And the beautiful thing is that, at least in the case of Netflix, and I know that many other companies have this pattern as well, is that Spark, when used, like let's say with Amazon S3, like as a kind of a cloud-based kind of a data lake, if you will, those like tables like are like actually physically stored as Parquet files. So Parquet is this efficient columnar data format for tables, and it's really widely used these days. And many systems, including Redshift and like pretty much all databases in AWS, they can export these Parquet files and push them to S3. And now the beautiful thing is that like when it comes to actually ingesting the data, the pattern that worked really well and avoided the denial of service attack is that, okay, so you execute the SQL, you use whatever query engine you like, maybe Spark, maybe EMR, like whatever. And then like those systems write these Parquet files to S3. And now the nice thing about S3 is that is pretty much the kind of the most scalable, most highly available like piece of software on earth. So you can hit S3 as hard as you can. So it doesn't ever go down, even like if you have 1,000 instances hitting it in parallel. And Metaflow includes a custom S3 client that was designed to actually maximize the throughput between S3 and these instances. So, and like you can actually saturate the network connection, that if you are like running, let's say you are like training a big model on a big GPU box that have like these days up to 20 gigabits per second, you can get like 10 to 20 gigabits per second of this data from S3. And the kind of really the curious fact about this, which many people don't realize, is that this is faster than like how you can load the data from local disk. So oftentimes there's this idea that, okay, if I had data locally, it would be faster. But like when using this pattern, it's faster to load the data from the cloud rather than from local disk. And that was actually really a productivity boosting feature, because it used to be so that like without features like this, people had to wait for many minutes or tens of minutes for, let's say, the SQL queries to complete. But in this case, you can just like ingest the data as fast as possible. So that's quite nice. And of course, like overall, this like a data processing is a deep topic. Happy to talk about that separately also if you have any questions. Well, now everything we have talked this far has been mostly about the, okay, so how do you create these flows? How do you scale? Well, I mean, one thing that still has been true in all these cases is that like it has been a human being like pushing the button and like executing the code manually. And now the closer you get to production, the more obvious it becomes that like it can't be like a single person like a clicking buttons, but it needs to be automated. So for that purpose, like we want to have these scheduled execution. So instead of you running it on your laptop or on your workstation, it's automatically running somewhere in the cloud. And now the interesting thing is that when we talk about workflows, there's the workflow itself, the kind of the abstract DAG that we express in the code, like we have those steps and self.next and so forth. But then like how you actually execute that workflow, that is somewhat an independent question from the workflow itself. And now when you run Metaflow in what we call local mode, like you do Python myflow and run, Metaflow comes with a built-in workflow scheduler. So it can actually execute that workflow for you, and like you can test it locally, and that's really nice. But now when it comes to running these workflows more in production style, there are other concerns as well. And like some of the most important concerns are that no matter what, these workflows should be, let's say, they should keep executing, let's say, every night. And like, even if the workflow scheduler itself somehow has trouble and it goes down, I mean, it should like come back up and like it should keep executing. Also, besides high availability, another really important concern is scalability, that this system needs to be able to handle potentially thousands of parallel workflows. So now you have this, imagine that like you have to build this orchestration system that can take potentially thousands of different projects. Each project can have thousands of different steps, and all this must run in a manner that like can never fail. And like building systems like this, orchestrators like this, is actually quite non-trivial. And interestingly enough, over time, Netflix has internally like built probably like a 3 or 4 different orchestrators in-house, because they evaluate systems like Airflow back in the day and decided that it's not going to be scalable, it's not going to be highly available enough, and so forth. And now, like when we open source Metaflow, we started thinking that, okay, like kind of what kind of a system that we could integrate with, so that would provide the same experience that we had internally at Netflix with the Netflix's own custom orchestrators. And we decided to integrate with the system called AWS Step Functions as the kind of the first example, which is basically a workflow scheduler that works in the cloud. It's provided as a service by AWS. It's pretty cost effective, and most importantly, it just works. So now many of you, like who may have run, let's say, Airflow by yourself, you may know that it kind of takes some babysitting. And of course, there are now other companies who would like to do that babysitting for you. But I mean, it's really kind of a non-trivial engineering question. And now the position that Metaflow has taken is that, well, like we have the internal scheduler orchestrator for like a local prototyping, but I mean, we can integrate with different types of schedulers over time, like for production usage, depending like what different companies need. So AWS Step Functions is available today. Like we are also looking into systems like Argo. Maybe Airflow could be one option in the future. But the idea is that like when you go towards production, you want an orchestrator that is highly available, that is scalable, that is easy to operate. Of course, there are other things like monitoring, alerting, stuff like that, depending on your company's needs. But as of today, the main thing is that like when you use, let's say, Metaflow with step functions, you only have to run one command and it pushes that to step functions. And now you have the very same code. You didn't change anything in the code, and it runs in the cloud in a very robust manner. So that is getting like a very close to that like production readiness that like we have been aiming towards. Well, one thing, you know, like like one interesting thing that we started noticing, like when we started scheduling these executions at Netflix, is that occasionally things still failed. And one of the most common source of failures was actually like caused by those external dependencies that we talked about before. So now the challenge is that imagine you have a project that uses TensorFlow, and like of course the simple way would be that you can just like a pip install TensorFlow. But now the challenge is that TensorFlow, of course, like it changes and evolves over time. So like today, I mean, like it used to be so that like prior to 2.0, like it was a different API. Now the API changes, and of course that breaks all the existing workflows. Or there might be more subtle changes that, and of course TensorFlow is a high quality package, but now imagine using something more experimental, and like these packages like break way more often. So what you want to do is that like you don't want to expose yourself directly to these changes upstream, but you want to freeze these execution environments and have at least the production execution should be as stable as possible. Now, the kind of a de facto way how many companies do this these days is by using Docker. And like now one approach is that you write Docker files by hand as a data scientist, and you manage a library of Docker files. Can get tedious. Another approach that many companies have taken is that there's a centralized Docker image that everybody must use. And while that is a pretty decent approach, I mean, the challenge is that if, like you assume that different projects have different needs, and this is what happened at Netflix as well, that there was one project that wanted to use the bleeding edge version of TensorFlow, whereas another project that wanted absolutely to use something that's much older because they didn't want to change anything. And now you kind of have this dilemma that, well, I mean, like, what do you have in that, like a common image? Do you install the new one and tell the old one, the old project that they have to just upgrade their code? Or do you tell the new guys that, no, I mean, like we are kind of stuck with the old version? So there's like a no good answer. And as a solution for that, like we introduced this Conda decorator in Metaflow, and like maybe some of you have used Conda, the package manager, before by hand. And what it does is that it basically creates a virtual environment for your Python code and like other code as well. And then it like brings all the libraries in that like you have specified here. What Metaflow does for you is that it basically removes the need for maintaining these virtual environments by hand. So you can just in your code itself, you can say that, okay, these are the dependencies you need. And then like basically Metaflow then uses Conda behind the scenes to instantiate these environments. What is super important is that like when you combine this feature, like with the, let's say the step functions create, when you push these things to production, then that environment is really frozen, like as if it was a Docker image, so that version will never change. And we actually snapshot the code in S3 and so forth. So you are not even at the mercy of whatever upstream package repository might be. So this was like one of the key features in like making these workflows more production ready, because now they are basically like really like hermetically sealed, like from whatever happens in the outside world, because both the code is snapshot as well as the dependencies are snapshot. And now, I mean, it's just like, as long as you can keep the data flowing in correctly, which is of course a big ask, like everything should be quite stable. Now, like kind of as we are like inching towards the kind of the finish line, there's the big question that, well, how do you dare to let's say upgrade your production version? Like, let's say for something like a Netflix recommendations. I mean, as you can imagine, like if you were to join Netflix as a data scientist and like you said that, okay, I have this new algorithm, like all it scales and like now it is like even like it's scheduled and like it has been running for like past 3 weeks, like flawless, everything seems good and fine. Well, would you dare to kind of change the Netflix UI like and then push it to production and like just kind of like pray for the best? Well, most likely not. And of course, like what most sophisticated companies do these days is that they run some kind of an A/B test. So instead of just having like one production version running, they have multiple different versions running in parallel, and then they can compare the results and like maybe expose the new version to a limited subset of users, so that if something goes wrong, like not everything is lost, and you kind of limit that blast radius. And this is a more advanced feature in Metaflow, but what you're able to do is that you can define these projects, like which basically is a way to group together multiple related flows. Like you can imagine that, let's say you have one workflow that trains a model, you have another workflow that takes the model that like was just trained, and then it predicts new data. And now typically what we want to happen is whenever like we have a new model, then we kick off the prediction flow and so forth. And these two things should be connected. Well, that is one thing. But now like the interesting challenge becomes that, like, let's say you have these chains of workflows, but you have multiple ones of them. So this may be branch A might be a production version. And now like a new person, you come in and like you say that, okay, I have a better version. Well, what you want to do is that you want to deploy that new version as an isolated chain of workflows to the production scheduler, so you can run them side by side. And maybe you want to kind of expose like your results to 10% of users and see what happens. And then like you can compare results. But actually, like just being able to manage these isolated workflows in a kind of a sane way. I mean, it's actually like an interesting kind of a bit of a kind of a bookkeeping challenge of its own. So that's why we wanted to introduce this ad project. We didn't have it originally, and then like we realized that, well, this is something really important, because like pretty much all complex projects need something like this. So now, like, okay, so now we went all the way from like being able to basically develop code on a laptop, while take it a little bit closer to the workstation, like the production environment in the cloud workstation. You can like still export data with notebooks, but I mean more production, kind of like a production ready way of doing it is to kind of write a workflow. So that's all good and fine. Then like as you execute these workflows, you want to keep track of the experiments, you want to keep track of all the different executions you have. So the versioning becomes important. Then when you kind of want to kind of like test your algorithms with larger amounts of data, you need to kind of start thinking about scaling. So first you can scale vertically, no need to kind of change the code at all. Like you just say that, okay, I need more memory, I need more CPUs, more GPUs. At some point you may want to use more machines. You can take care of that like using horizontal scaling. Then like the question is, how do you access data? Well, I mean, you can just get it fast from S3. And then like, how do I schedule this so that I don't have to keep clicking buttons by myself? You can interact with these production schedulers. And like in order to have a stable execution environments, you want to freeze the dependencies. And finally, like you want to be able to A/B test everything. So now like kind of you might think that this is the kind of really the finish line. And in many ways it is, except that like what happens is things always fail. And of course, there are like all kinds of, I mean, basically everything can fail. I mean, your models can fail. Oftentimes the data has issues, the machines can fail, and so forth. So it is useful to really start thinking about that. How can we be prepared for these failures? And like one of the key things here is that like this is not a one-way street. And like, of course, you have heard many people saying this, that it is definitely an iterative process, that like you go to production, then something fails. You want to go back to your like workstation and try to understand how you can, well, fix problems and also improve the model. And for that, like we have a couple of different features. One is that, of course, like as much as you can, like you want to kind of increase the robustness of your code by introducing things like retrying, or like there's this catch thing that, okay, so if building one model fails, maybe that's fine, and like you can still move on, and like maybe you can have a failback, like a failover option or something like that. But maybe even more importantly, and this is something like where many systems fail, and it's kind of like surprising given like how much time ends up being spent on debugging these production issues, is that like, let's say there's the one command that allows you to go to production, but how do you come back from production? That is really the key question. That like, imagine that like one night you get pager duty alert like at 4 a.m. like saying that the workflow has failed. What do? All data scientists and software engineers, well, the instinct is that like you try to understand what went wrong, like maybe you go to the logs, but at some point, I mean, you want to kind of reproduce those issues locally. And in those cases, in order to reproduce the issue locally, you kind of need those artifacts so you understand the state of the workflow when it failed. But you also need to be able to kind of run that, like a test the thing like locally, like in a reasonable manner. So what Metaflow provides is that like we have this resume command that allows you to specify that, okay, I want to resume, and like now this is like running on your local workstation, that I want to resume this, like let's say an execution that happened now in the production scheduler last night, it failed, but I mean now I want to run it locally and see what happened and if I can reproduce that issue. And now let's say you can reproduce that issue, you see, and like you realize that, oh my gosh, I was dividing by 0. What you can do is that you can fix the division by 0, and like you can kind of push it back to production. But I mean, much of the, of course, the kind of the operational life of anyone like operating these things in production, like as let's say as an ML engineer, is about iterating like between pushing things to production and like understanding like what happens in production and like fixing things. So also keeping this cycle as fluid and frictionless as possible is really important. So now I just want to quickly like summarize the main lessons learned. So as I mentioned, well, I mean, the path to production is definitely incremental. So this is really, really important that there isn't a binary prototype and binary production, but there's just like a whole, like a scale of a spectrum of things in between. And why this really matters is that different projects are at different phases of their life cycle. So let's say the recommendation system at Netflix is of course super, super important. Like everybody absolutely hates it, like if Netflix goes down Friday evening. So that must never fail. I mean, it's kind of the highest SLA, and they're dedicated people whose job is to make sure that that never fails. But that's of course not true for many other projects. It might be that, let's say you have this one new project and like you are just like prototyping a crazy new idea locally, and nobody has like any expectations that it would work. So failing is okay, but maybe you still need to scale. In some cases, let's say we are executing an like A/B test with the new model. So it's still in kind of a production, but I mean, maybe there's a failover path that like if the new code fails, then like we can fall back to the previous production version. So there are no like visible effects to the user. And in which case, I mean, still the SLA needs to be high, but I mean, not quite as high as in the main production version. Or maybe in other cases, the project is at the phase that, well, they just want to scale it to more data and they maybe want to run it daily. But I mean, other than that, I mean, like, kind of it really doesn't matter if it fails every now and then. Or in some cases, it might be that the predictions go to some kind of a system, like a decision-making systems where humans can actually like see, and the models are understandable enough that they can see if something is wrong and they can take actions to kind of remedy those issues. So the point being that even production is really a spectrum. And like if you only support like one type of production, it can really hinder your productivity, because either it is so that like everything is totally crazy and like you just hack everything in a notebook, or it is so that that like everything must be like a super like hardened, and like you must write Docker files by hand, and it's a lot of work to get anything even kind of close to being able to test at scale. And of course, then kind of the main thing here is about that like all these layers of the stack matter. So you need to think about data, you need to think about compute, orchestration, versioning, and of course all these like issues related to kind of a modeling itself. But there's this like a nice distribution of responsibilities that work really well for us at Netflix, and I have seen working well at many other places as well. That when your infrastructure can support it, you can have an infrastructure team that really focuses on the low level of concerns, and then like giving a lot of freedom for data scientists at the top of the stack. And the main thing, like how we think about Metaflow, is that it really boils down to the question of like data scientist productivity. So ultimately, it is a productivity tool. So everything we talked about, it's not about making something technically possible that would have been impossible in the past, but it's rather that like, how do we make all these people productive who build all these different kinds of applications? And the idea here is that optimizing the kind of the time use of these individuals, these humans, is more important than like optimizing the time, how long it takes to kind of spend like kind of compute like one of these nodes here. Because ultimately, especially in a larger organization, all these things kind of get amortized like over multiple projects, but it's really the human time that matters, and like their capability of like executing and operating many things in production. Now, like when it comes to technically implementing kind of something like this, and like how we went about Metaflow as well, is that of course we realized that we don't want to reinvent wheels at all. So the way how we see Metaflow is that like we integrate with all these different systems like AWS. Now we are working on Kubernetes integrations, like we integrate to Spark, like Argo is another workflow scheduler. Many people use something like Jenkins as a CI/CD. And then Metaflow is basically in a way a kind of a user interface layer on top of this like a low-level infrastructure that then like, again, I mean, boost the productivity of data scientists. So the kind of the amazing thing is that like just let's say the kind of a scalable workflow orchestration is a really demanding engineering problem by itself, and it's actually not even specific to machine learning. So we can use whatever like a best off-the-shelf tools, and like a compute is another good question. That how do you manage a fleet of thousands of containers? Definitely something that's not machine learning specific. You can as well use the best tools out there like Kubernetes or AWS Patch and so forth. So this is, of course, like kind of the plumbing is a topic of its own, and like happy to talk about that if you have any questions or like if you want to follow up about that. I just now like kind of towards the end, like want to pitch that if you are interested in any of these topics, I've been also like kind of like writing kind of a more details in the book, because I always feel that in a presentation like that, it's kind of hard to go into enough details. So there's this book available at this site. It's called Effective Data Science Infrastructure. So basically you will find like many more details about all the topics that we discussed today. But like finally, like if you want to like talk with us in person, like there's this like very friendly community Slack at slack.outerbounds.co, and you are very welcome to join. I mean, even if you're not interested in Metaflow, I mean, you can just like chat about everything related to machine learning and machine learning infrastructure. So that's it. Thank you.
Great. Thanks, Vila, for the great presentations. We have quite a lot of questions in the chat. Let's start go over those questions. Just quick reminder, you have questions, please post to the chat. And oh, by the way, when you post in the chat, make sure you select to everyone, not just to the host or the speakers, so everybody else can see the questions. And also, if you prefer to speak, to ask questions, feel free to raise your hand. I can unmute you to speak, to ask questions.
So Bill, I can see the questions. Should I just like go over them one by one? Or?
Yes, you can just go over one by one.
Okay, so yeah, like I guess like Joseph asked that like, would a more appropriate name for this be ML or data orchestration? Well, I like first, I mean, like, of course, like I missed it. Like, what is this exactly? I mean, Joseph, can you actually like, can people talk?
Yeah, they need to raise hand to speak. Maybe you can go to the next one,
Okay, well, anyways, yes. So I mean, many of these things are like equally applicable both to ML and data. So, okay, so yeah, someone post the link to Will High's talk. Okay, let me try to kind of just fast forward to the next question. Yeah, there's a lot of good discussion here. And okay, what if self-params from streams of sensor data? The idea is that, okay, what is kind of like a continuous, like a stream of data instead of like a statically defined set? Yeah, that's a great question. Like a streaming data is overall, it's a really a deep topic of its own. Well, I mean, I can just give a short answer that like one way of dealing it is that like you do some kind of micro batches as usual. So you could, let's say like once an hour, you can take the batch and then like you do sharding. But I mean, obviously, like if you really need like a real-time data, like a streaming data processing, I mean, yeah, I mean, this approach is not applicable. Let's see, I guess like any other framework suggestions apart from pandas? Yeah, well, I mean, definitely that's a brilliant active area of development at many companies. We are big fans of Arrow. Arrow, of course, it's kind of a more like a low-level component, but I mean, way more memory efficient than pandas. And now let's say if you have large data frames, there are like systems like Dask that help you to kind of handle larger data frames. And like something like Metaflow works really beautifully well with Dask, so you could do that. Or like, let's say Spark, of course, has a like really efficient data frame implementation as well. And of course, I know that in the Python universe, there are like all kinds of packages. Also, I can just mention that Metaflow also works very nicely with Numba, the compiler. So if you need large amounts of data and like you need something more efficient than pandas, using NumPy matrices with Numba is actually like a solution that works really well for some cases. But I mean, definitely requires a bit more work. How do Parquet files allow for faster reads from the cloud and faster reads from disk? How does it happen? Well, I mean, that does like happen for the simple fact that depending on your instance type, but the disk bandwidth, like on a basic instance, is about 3 gigabits per second. So you basically have a basic SATA adapter. I mean, of course, you can have a different kind of RAID setups and so forth that allow you to increase the local disk throughput, but it just so happens the network interfaces are faster than the local disk. So that is surprising. And like, if you wonder that, like, well, kind of how is it like physically possible? Well, I mean, this assumes that like you go from network to memory without hitting the disk. So if you go directly from network to memory, then like you don't obviously like have to do anything with local disk, and it can be faster. Now, if you have to go via disk, obviously the disk becomes a bottleneck again. So you need to size your instances accordingly. So I heard that in Netflix it's used Iceberg. Yeah, no, Iceberg is really a great project. Yeah, no, I mean, again, I mean, it's a deep topic with Iceberg. So, I mean, for people who don't know what Iceberg is, it's an Apache Iceberg project, open source replacement for Hive as a table format. So you can go and look it up. But yeah, I mean, join our Slack if you want to talk more about Iceberg. It's a deep topic. So Bill, are the slides going to be available? I mean, can we put them somewhere?
Yes, it is. You can share the slides, either the hard copy or the link. I can share to the attendees.
Okay, so yeah, we will make that happen. Are you saying that Metaflow can completely supersede Apache Airflow? No, actually, like the idea really is that you can, well, I mean, as of today, you can't like use Metaflow and I mean, there's no direct integration between Metaflow and Airflow, but I mean, technically one day, if there will be, I mean, you can use them side by side. Now, technically, when it comes to orchestration, of course, like you can use Metaflow's local orchestrator as a replacement for Airflow to a degree, but I mean, that's not necessarily the kind of the main point, because Airflow, of course, like it does many other things. I mean, it has a nice UI, and it's not specific to ML, like, whereas Metaflow is really specific to kind of all these like ML data science concerns, and then it works nicely with other orchestrators like Airflow and Argo and step functions and so forth, hopefully with Airflow at one point as well. So let's see, there's a question. How is it that a Netflix data scientist with the say an economics background learns how to make distributed systems compute storage trade-offs? Yeah, no, I mean, totally they don't. And like the expectation is that you don't have to. So a good example, like when it comes to, first, let me take a step back. Like building large scale distributed systems is of course very, very hard. I mean, it's like hard for like engineers who have been doing it for a long time. And now the hope is that, like, let's say people who are focusing on ML and like the data science problems, which is also a hard topic of its own, that you don't have to kind of get 2 PhDs, one in computer science, another one in like, let's say in stats. So the idea is that like Metaflow makes it easy enough to, let's say, leverage distributed computing like through vertical scalability and the horizontal scalability with for each, so that like you don't actually like have to much think about these typical issues like synchronization and like many issues with fault tolerance and scalability that you otherwise would have to think about. Also, like especially with vertical scalability, you can actually just like write the code as you would be writing it in a notebook, and you don't really have to kind of think about like anything about distributed systems or the cloud or anything. And it's mainly the kind of the abstraction that you have this like a massive size laptop that happens to have, let's say, 0.5 terabyte of memory, and you can just like write code as before. So I mean, then of course, like the kind of a like higher up you kind of go into that stack of, or like kind of a, I guess like a lower you go into the stack of like building larger scale systems that are more and more demanding. Of course, there are things like fault tolerance that you have to think about, but still that's way easier than, let's say, using Kubernetes directly. So. Is there a Metaflow, some sort of a console for the entire set of active Metaflow deployments? Yes, actually, there's a, if the question is about the kind of being able to monitor these things, so there's actually a UI under construction that hopefully will be open source soon. thinking about the intervention of a production rollback. Yeah, and like when it comes to overall these like production deployments, another deep topic of its own, many companies have set up some kind of a CI/CD system, or they integrate with their existing CI/CD setup so that, let's say, data scientists can test things locally on their machine, but in order to push something to production, it goes through some kind of a CI/CD, and then you can piggyback on your existing CI/CD mechanisms to kind of do rollbacks and whatnot. So. Time permitting, what is the outer bounds vision for Metaflow forward? Well, I mean, I can give you a short answer that like we are like 100% focused on like advancing the open source. Definitely join our Slack so you can see all the topics that are being discussed, and like you can also like affect the roadmap right now. So my like view overall of the landscape today is that like there are many companies who need to do something like this besides Netflix, and it's just like a fascinating how many companies in different industries are like starting to apply machine learning and data science, and they are all like facing the very same questions that we started with, that how do you access data, how do you access compute, how do you do versioning, and so forth. And there aren't like that many great solutions in this space today. There are many point solutions, but like stitching together a functional platform like out of these point solutions, it's actually a lot of work. And like now our vision at Outer Bounds is that like, well, I mean, we want to keep developing Metaflow and hope that it like works for other companies as well as it does for Netflix. And then of course, like if you wonder about monetization, well, I mean, over time, there are like features that like especially large enterprises care about, let's say something about data governance, security, and so forth, that may eventually become commercial add-ons. But I mean, like when it comes to open source, that will always stay open source. How does monitoring work for Metaflow? Yeah, I mean, yeah, you can definitely use things like CloudWatch, Datadog, like whatever like a tooling you have out of the box. There are actually some examples out there how you can do like a very specific, let's say, memory or CPU profiling for specific tasks. There's a GitHub issue if you go and like look for that. So that has a few examples. But yes, the basic idea is that you can use your existing tools. So Bill, by the way, do we have time, or like there are like a few more questions left? I believe.
Yes, please go ahead. Yeah, we have time to go over all of the questions.
Okay.
And also, just by the way, anybody want to speak to ask questions, and I enable everyone. You can feel free to raise your hand and speak to ask questions or comments. Mm-hmm. Go ahead.
Yeah. So the next one is that, can you share more details of how reproducing a particular production run works? Do you snapshot all data inputs of all runs? Well, that's a great question. So how it works is that we snapshot the internal state of the workflow, meaning that when you do something like a self.x in the Metaflow workflow, those things get persisted to Amazon S3, which then like allows us to resume the execution locally. That we can, I mean, we also persist the code, so you can take the code, and then like we can take that like internal state, and then you can say that, okay, resume the execution like from a certain step. Now, of course, it is possible that, let's say, if your code accesses external resources, like gets data from a database or something, well, we don't snapshot those. So I mean, it's not like perfectly reproducible in that sense. In some cases, it might be okay if your database, let's say, also is versioned enough, and like you're like a discipline that like you always refer to one immutable version, so it may be fine. But yeah, I mean, it doesn't like magically like freeze the kind of the state of all world. When it comes to larger data sets, the kind of a recommended approach today is that instead of just like replicating all data, basically like sucking in the data from your data warehouse as Metaflow artifacts, instead of that, you can store pointers to large data sets as Metaflow artifacts. So then like when you need to, let's say, like resume something, or like just like run the same thing again, you can basically just use that pointer to go to the snapshot of data in your data warehouse. So that like then you don't have to have duplicate like copies of large data. For small data, I mean, even having duplicate copies is actually not the big issue, but definitely for like in like a terabyte scale, I mean, that wouldn't be a good idea. When do you think it is a good time investment for a team to try out Metaflow? E.g. when they don't have any pipelines in place, or if they do already have a process in place? Well, I guess the idea here is that getting started with Metaflow, or like just testing Metaflow, is easy enough. So you can do pip install Metaflow, then like there are like some built-in tutorials. I would say that given that like just like seeing how it works is so easy, I mean, you can just give it a try and get a feel if it like addresses some pain points that your team has today. I mean, of course, let's say if you are a single grad student, like writing a research paper, and like you can do all that in a notebook, well, maybe like you don't need Metaflow for that. And like maybe if you have already a process in place and like you absolutely have everything works swimmingly and like there are no issues, well, I mean, don't break something that works. But I mean, like if you have any issues with experiment tracking, dependency management, like running large scale compute in the cloud, or like handling this like a more complex projects or anything of that sort, I think that would be a good motivation to at least take a look. How does Metaflow play with other cloud service providers like GCP and Azure? Great question. Kind of on the roadmap eventually to integrate with these systems. Right now, like what we are doing is that we are integrating with Kubernetes. As you may know, like you can run Kubernetes clusters in many different clouds. So that might be a path like a forward in the future. But I mean, I would say that's still like kind of a months out, like before you can like easily like run it in these other clouds. Now that being said, like what you can do is that you can definitely launch an Azure instance or like GCP instance and like use Metaflow inside that instance, like in the local mode, and that actually works quite fine. And that might be like even like beneficial in some cases. So definitely an option. By the way, I mean, like feel free to reach out to us at the Slack if you have like needs for other clouds as well. Okay, another question: can Spark and Dask data frames be pickled with store magic? So I guess, yeah. I mean, I guess that's not exactly a Metaflow specific question. Yeah, no, I mean, when it comes to serialization of any kind of artifacts, it can be tricky. The kind of the position that we have taken is that given that it is like practically impossible to have any kind of a universal serialization format that like works for everything, and like even pickle doesn't work, like not for all objects. So let's say you have a more like complex model, like a Keras model or something. Instead of pickle, I mean, you probably should use the kind of the objects or the models like a native serialization method. So, and what you can do is that you can use the native serialization method and then like store the bytes that you get from like that serializer, like as a Metaflow artifact. And then you do on the other side, like then you just like a deserialize like from the bytes to the object. And the same thing applies to data frames as well, that I know that some companies have this like a tiny wrapper function that let's say like a serializes data frames as Parquet and then loads from Parquet. So if Parquet is something that works for you, I mean, that's an option. And like eventually, like it might be that like for something like data frames, like let's say could do the Parquet serialization under the hood automatically. But yeah, I mean, for more complex objects, I mean, you kind of may need to kind of do it kind of like whatever like works best for the object in question. And I think that this is the last question now. Curious how you got Netflix to agree to split off Metaflow into a new startup. Do they retain some stake? Well, I mean, the easy thing there is that like if you go to Netflix/Metaflow, you can see that it's Apache licensed. So in that sense, like even if you wanted to start a startup, like kind of using Metaflow or commercializing Metaflow, I mean, yeah, I mean, happy to help you doing that. So that works beautifully. So like in practice, we of course like do work closely with Netflix. So Netflix like is of course a huge user of Metaflow, and they're like people working on Metaflow internally at Netflix. So, and like you can actually find all those people on Slack as well. So I mean, the idea is that like it's better, of course, like to all like work as a big community. And then already now, I mean, Netflix has benefited from some contributions that other people have made, and like hopefully those contributions from the outside will only increase in the future. So I think that was the last question. So great questions, thanks a lot, and like happy to keep chatting and